Cockpit from ground.
Go ahead.
Sir, you may now start your engine number 1 and number 2.
Starting 1 and 2 sequence.
Yeah, go ahead.
Okay. Starting 1. The air valve start opens. It starts the engine turning. See the N3, N2, and then N1. When it gets a certain number, the fuel be fed in, which is indicated there in a minute. It's got to wait for the engine to cool down below 100 degrees.
Cockpit from ground.
Go ahead.
Sir, pushback completed. Please set your parking brakes.
Brake set. There you go. It's below 100. The fuel is fed in, and the engine accelerates. It's all done automatically for us. Should there be a problem during the start, the engine will look after itself. Modern technology. Okay, when it gets to about 50%, the valve will close, so the starter disengages and the engine will just keep on running by itself. That's the generator kicking in. That's disconnected the starter now. So the engine is running and it says available. Starting 2 at ground.
Gulf Air 155, may we follow the Philippine Airlines on Charlie?
Taxi Gulf 9 Charlie, runway 06.
Okay, behind Philippine Airline, Charlie 06 for Gulf Air 155.
Check.
All set.
One rotate.
Copy 155 departure, land type level 150, deferred advice, maintain runway heading.
Flight level 150 and runway heading Gulf Air 155. Thank you.
Airfield 2057, direct departure.
Heading.
Terminal 15,000.
Departure 7501, good morning. Heading 110, back 1000, line 3.
1201, good morning, flight 7000.
Line 7000, 7501.
Observe the waypoint.
Left at 0. Turn right heading 180, next 501.
better than yesterday. It's a little bit sunny one.
531 approaching 7000, November
501, land level 15.
Airfield 2546, establish on the localizer, ILS runway 069 miles.
Airfield 2546, contact tower, 118.1.
118.1, good day and thank you, Airfield 2546.
Good day, sir. That's 501, contact 119.7.
Pitching 119.7, that's 501, good afternoon.
Good up. DDB 454 Papa, descend 2,500. Clear the ILS runway 06.
Okay, thank you.
Thai 620, revise. Turn left, heading 030 and cleared for ILS runway 06.
Heading 030, clear ILS, airport 006, 620.
Jaguar 626 approach. Confirm proceeding to Tangley number.
Negative, sir. Overheating indoors. 4,000.
Roger, and confirm you'll maintain 4,000 feet.
4,000 feet, let's go.
Roger, sir.
Okay. Full. Standard.
113.
Yes, sir.
Okay,
Baro reference.
155, contact control 118 decimal 9.
118 down to Gulf Air 155, thank you.
Thai 6.
History understood.
Standard, sir. Thank you. Checks is complete.
03, final 3.
Traffic at 11 o'clock, 64 miles. Flight is on Airbus, descending 220.
Okay, Gulf Air 155, lucky.
About 92, we do traffic, about clear. Inclusive.
Should have a try. She got, she got beautiful smile.
Hello everybody, I'd like to introduce myself. I'm Yusuf from Bahrain. I'm the cabin senior here on this flight from Manila to Bahrain, Airbus A330. We're starting now the service, and I'll tell you something about how long I've been working here in Gulf Air for almost 20 years, and I love this job. I was very interested to see different places, different culture. Everything is nice in this job. The important things about this job, the safety. Safety will come first before the service. And we'll try to bring everybody to satisfied with us before they will leave disembark this aircraft. We're so happy we're doing this to everybody. And I hope you will enjoy this interview with us. Thank you very much.
Hello, back again on this flight 154. I'd like to welcome you on this flight. We are now 4 hours and 15 on the flight and the cruise. My name is Captain Mahmoud Al Ansari. Although I'm sitting on the right hand seat, this flight is a long flight, 10 hours, so we are augmented flight. And basically there are three captains. Captain Nader, which was a commander, and myself, I'm today acting as a co-pilot. And also we have good captain at the moment. If you can look at him, is another captain. Captain Muhammad Khaldi is now in command for this portion of the flight. Now, we are on the cruise. We had some turbulent, and it was forecasted, it was unavoidable. Now, as we have now a very nice, comfortable ride, we thought it will be a good idea to just take you a little bit through the cockpit and show you the instrumentations and all the indications. First of all, this cockpit of A330 Airbus is called a glass cockpit, which means that has got cathode ray tube screen, and you don't have many instrumentation, which was the old analog. So it is all CRT, cathode ray tubes, screens with a digital indication on it. On the past, there would have been 6 or 7 instruments in front of the pilot, each pilot, which has been substituted by 2 TV screens. This is number 1, it's called PFD, Primary Flight Indication Instrument, and this is called ND, Navigation Display. Now, this has got, of course, the artificial horizon, which shows how the aircraft and relative to the horizon, whether it is straight and level at the moment. If I take the flight director away, you can see the dot represent the aircraft, and these represent the wing of the aircraft, and the blue represent the sky, and the black represent the ground, and the aircraft looks sitting between the sky and the ground, which represents the setting on the cruise, and this is indicating the pitch of the aircraft, the nose of the aircraft on the air. Now to the right of it is showing, I don't know whether you can see it, 38,000. This is the altitude of the aircraft on reference of the standard day setting. All the aircraft, they put a standard day setting of the pressure, and this will give you the representation of the standard altitude of our flight today. To the left of that, it shows a tape with some speed on it. At the moment, this is called airspeed indicator. So basically, this instrumentation is one flight instrument, another flight instrument, that's number 2, another flight instruments, all being combined together. Now, let's look at the 4th flight instrument, which is this one, which you don't see anything on it. You just see a graduated scale with a little horizontal bar, green bar showing at sort of horizontal. Because this is called a climb and descent level indicator, VSI, or vertical speed indicator. It just shows at what rate of climb, how many thousand feet per minute the aircraft climbs and descends. Because it is level, it is showing at neutral position. So this is not doing anything at the moment. Now, so this becomes number 5 instrument. If we look on the bottom of this is called the compass. So this is instrumentation number 5, which is all been put on the screen. And at the moment, on the rubber line shows that we are flying heading 285. Okay? Now these are the instrumentation. Now the designer, what he has done, he has also put some indication on the top of the screen. This is called annunciators, which is give the pilot indication is of what type of the mode that the aircraft is on. So, and there are 5 annunciators here, 1, 2, 3, 4, 5, and each has got different information on it. We take it from left to the right. The left one, it is written on it Mach. So at the moment, it tells you that the aircraft is flying on a Mach mode. Mach mode mean the Mach is as a glossary that is used in flying, which is mean the relative speed of the aircraft and proportion relative of the speed of the aircraft speed of sound at the sea level. So we are flying 82.5% of the speed of the sound. Okay, something to add. The next box there, it shows that the aircraft, it's maintaining cruise altitude. It is at its designated cruise altitude. The third one shows that we are on a navigation mode, which means that the navigation mode is engaged to the automation, and the computer of the aircraft, which is the flight management system, is looking after navigating the aircraft through the flight. Now this portion has got nothing on it. This portion usually will be lit when we are coming for approach. Okay? So, and when we're using approach, this comes in a little bit. The fifth one is the annunciation of what type of automation is engaged. So there are 3 lines. AP1 mean autopilot 1. So if you just turn the camera here, it will come and say that we are autopilot 1 is engaged. This in the center is all our automation. So it's got autopilot 1, autopilot 2, and auto thrust 1, and then the rest of automation. Now without I'm looking here, if I just concentrate here, it will say to me what is happening here. So it's autopilot 1, I have flight director 1 and 2, and this shows that the auto thrust is engaged and actively looking after controlling the speed. So can you see, it's a lot of talking about the primary flight display, PFD. It has got a lot of information. Designer put it on one little screen, which made the life of the pilot very easy to scan them. Before, the eye of the pilot should come at each angle of this big board, backward and forward. So the scanning cone of the eyes was a little bit wider, which was more tiring. Now the scanning cone of the eyes is a little bit more narrower, which is more comfortable. So now this is enough about that. So if you look on this one, this is called navigation display. And this page is usually the standard page that it is displayed at the moment because we are on the cruise. And this is the preferred page for the pilot at this stage of the flight. So this shows, first of all, the position of the aircraft. That's representing the position of the aircraft. And the green line shows the airways that we are flying at. So if we look at the moment, we're getting very close to this position called Mabur. And then ahead of us around about 165 miles as a position Orkok. And then on the same line, we are going to a position called Dogom. So the green line represents the center line of the airways, which is being designated to us by the ATC. And we are exactly on the center line, shown here by the automation and the display. Now, then we have got some more information around this screen. Now, if we look at the left-hand side corner on the top, it gives you ground speed of the aircraft. And the next one, then next to it is true airspeed. So ground speed, true airspeed, and the bottom shows the wind. So this gives you the effect of the speed of the aircraft being affected by the wind and the resultant of the ground speed. At the moment, we're having a wind which is facing the aircraft forward, which means slowing the aircraft in relative motion on the ground. Therefore, our true speed is 485, 488, 478, and the ground speed is much lower because the wind is slowing us back as an effectively cutting our speed on the ground. Now, this is number one. This side of the portion, it shows you that particular waypoint that you are navigating to. It shows Orkok. And on the display here, on the center, it shows Orkok is ahead of us, some sort of 100 something 60 miles. But here clearly it will shows Your direction to Orkok in degrees is 285. Your actual distance to Orkok, it shows 173 mile very accurately, but this here shows a little bit roughly, and also shows the time from now to Orkok is another 8 minutes and 31 seconds. Okay, so that is the top right hand corner. Now, the first arc also here, and this represent arc of the compass. So if I want to know what heading I'm flying or what track I'm flying, I have the reference of the compass displayed on the top row arc here, which gives me indication that I am flying a track of 285, and it agrees with the track which is showing there. Now, the rest of the arcs, which is dotted line, shows the distance in the arc up to the end of the last arc, because this distance also can ascertain to the pilot what are the distance between each waypoint looking at the arc itself. So at the moment, this distance arc is 240, this distance arc is 160, and this distance arc is 80. So this means that between each there is an 80 miles arc difference for calculating of distance. Is another way of calculating distance. If we look at the bottom line here, it shows something in pink or violet, MORA. MORA is a minimum en route safe altitude for the aircraft on the particular route at the moment. It shows that at the moment, because we're flying over the sea, that MORA is very low, it's 1,000 feet. So our safety height on this particular instant, at this position, we can go up to 1,000 feet and we're still safe. This bottom line, it shows times. Time from takeoff up till this time is 4 hours and 13 minutes. The other corner on the left side and right side shows us any navigation instrumentation that we can tune. At the moment, this shows that we have got VR tune 1 and VR tune 2. Basically, we don't need the VR to be tuned at this position because we are flying on global navigation system, which means that we are picking up signals through our automation from the satellite, and the satellite, with the help of the navigation system of the aircraft, will guide the aircraft very accurately up to 100 meters almost on the things. 100 meters on the sky is really nothing. On the past, the deviation could have been up to 10 miles. So now we are getting to 100 meters. Anyway. So this is the two instrumentation that I have in front of me as a co-pilot. And if you just turn the camera toward the captain, you see exactly identical instrumentation. Okay, he's got that. Now, coming back to this, you see I have one indication and he has got different indication there because he's changed his display. So in the front here, on the brow, the eyebrow of the aircraft, where the rest of the instrumentation is an automation, are the switches and selector that we can change the mode of this. So at the moment I can change the DME mode of this thing. So this looks different. So these are the scale mode, which is changing the DME arc. I can change the display to make it look different type of display. And I can even change it to indicate engine instrumentation. So by flying glass cockpit, we can convert any one of this instrumentation to read anything. So I'm substituting the center instrumentation panel, I'll bring it here. Let's say if this fails and I don't have any engine instrumentation, by just fiddling the switch here, it will give me the indication of my engines over here. So this is give us a redundancy for dispatch. Okay, now coming back, we say the co-pilot, the captain has got same instrumentation. Now we come to, now we come to the center instrument panel. Of course, center instrument panel is the panel which is common to both the co-pilot and the captain. So this is a common panel between both of us. Because we don't use it for flying, so we don't need a duplication. One center instrument panel is enough to indicate for both of us. This is called engine instrument display, primary display, and this is called the system. Understand? Okay. Now, on the engine instrument, we have the first three layers of the instrumentation is indicated to the pilot. The first one is called EPR, engine pressure ratio. The second one is called EGT, the temperature of the engine output gas turbine. And these, the third arc or the third indicator showing the RPM of the engine shaft. This engine is a Rolls-Royce engine, and it has got three multi-shaft integrated with each other, flying at different speed for maximum efficiency. So each percentage of the shaft speed are showing on the different things. One is showing as an arc, one is showing as a number, and then the third one is my captain selected is showing on another indication here. Now we have selected a different indication which is giving us the rest of the engine indicating instrument that it is usually hidden. We don't need it. Now that one was not needed. So on the cruise we have this is as a common page. But if something goes wrong and the captains and the co-pilot want to make a little bit more analysis to see what is the rest of the engine instrument doing, he just press a small button here and he will see all the engine instrumentation here coming, showing the RPM of the third shaft, the fuel used, oil of the engine 1 and 2, the pressure of the oil, the EGT, the temperature of the oil, and the vibration of each shaft and the nacelle. So all this is a good indication for engine instrumentation, but you don't require it consistently. So therefore the designer made what? Made it hidden, and he just displayed one cruise page. So if we look at the cruise page, which is a standard page, it's a combined page of engine and air and some of the pressurization. So I'm going to combine so many pages to give you sort of indication to be good for you for the cruise, and it is called cruise page. Now on the engine page, which is the upper part of it in the center, it shows the fuel flow on each engine and fuel flow total, and it shows oil, which is very important to both engine. So if you look, oil is important for me, what the engine oil doing. So it is shown for me here. And it shows the vibration. Vibration is very important. So it's been put on the common page of the cruise. On the lower part of it, it shows you air, which has been the pressurization system. I want to know as a pilot, where is my cabin altitude at the moment and what is my pressure differential. And that is enough. And the mode is auto. And then in the little indication here, it is called the air conditioning the indication, which shows all the different zone of the aircraft plus the lower cargo, the temperature indication. So the temperature indication is very important. So it is shown on the common page. The lower part shows a little bit more technical, shows the temperature of the outside and the temperature of the outside and relative to the friction. So we have got the static temperature, which is this one, 52, and the combined temperature of the outside and related to the speed of the friction, which cause a temperature rise. This shows the time, which is a clock time, GMT, and this part shows to the pilot is also an important gadget, the weight of the aircraft at this time and its center of gravity of the aeroplane at the moment. So this, all the information at one glance is very important to the pilot. It's been picked up from 1, 2, 3, 4, 5, 6. So it's been picked up at least from 12 systems put in a very abbreviated form for things. So now, if I want, because on the past, these aircraft, it's called glass cockpit, most of the system part of it is hidden. It is controlled by computer. If I go back to the old aircraft had a big board to the backside of the co-pilot with a lot of gauges, which is called system panel. And this system panel shows similar this sort of indication, but in analog form, and shows different system. But for this screen is looking after it, and if you come just a little bit here in this unit there, that unit where I'm pointing, these are a lot of black switches. One called engine, bleeds, pressurization, electric, DC, electric, AC, DC, hydraulic system, circuit breaker pages, APU page, conditioning page, door page, wheel page, flight control page, fuel page, and all pages. And then there are some more switches, clear, state is this. Now, this on the past aircraft, this particular board was a board at least of 140 centimeter by 100 meter or maybe 120 meter board, which was behind my back. This has all been simplified on this small little board, miniaturized. But if I press one of the switches, the indication here has changed. So it shows me the lower engine page in more detail for analyzation. If there was some problem with the engine, let's say if it has EGT or vibration, I can come here and do some analysis. If I press the next switches, it shows me another system. It shows me the bleed page. It shows me, give me a pen, please. I don't know what I've done. Yeah. It shows the bleed page and the schematics, IP air, which is intermediate air, HP air, the temperature and pressure of the air, and these boxes are representing air conditioning units. So it shows where the air pressure from the engine is coming, how it is feeding the pressure, the air conditioning packs, and how the cold air coming to the aircraft. Now, if I press another page, which is the third one shows me in detail what is the pressurization system doing to the aircraft. So here it shows cabin pressurization, but it's got more detail on it. It shows that we are an auto. This has got 0 VS, mean 0 feet, mean that the cabin of the aircraft is neither climbing nor descending, because we are a steady state. Shows pressure differential of the aircraft, the rate of climb of the cabin of the aircraft, and the cabin altitude of the aircraft. So this is representing the oxygen level altitude to the passengers. So at the moment, the passengers are exposed to an oxygen and pressure level of being at 6,000 and half, 6,500, although we're flying at 38,000. The lower part shows the position of some valves on the aircraft. It's called pressurization valve, forward, aft, safety, and extract. This valve controls up and down through the automation, which controls the pressurization and keeps the pressurization in comfortable mode. So if you go to the next page, it shows the electric generators supplying the electrics. This is called AC. If you go to the next page, there shows again electrics, but this time it's a DC electrics, written DC1, DC essential, DC2. The difference between AC and DC. DC is a direct current voltage, and these are required for driving all the instrumentation, and any avionic requires DC. A lot of part of the aircraft, because it is working on computer and avionic, it works DC. So we have got a lot of DC circuits on this aircraft. Coming back to the next one, hydraulic. 3 systems backed up by the 4th one here. Although we have got, it's a 4th, almost 3 system, but backed up with 4 pumps, which means that the green system, which is the major part, is being driven by 2 pumps. But the aircraft has got 3 systems: green system, hydraulic, blue system, and yellow system. If I go back to the second line, APU, auxiliary power unit. This is a small turbine that we turn it on maybe sometime before landing or after landing nowadays, and that gives us pressurization control, air conditioning control, and also electrics on the ground. So when we are on the ground and we don't have the engine running, of course, while waiting for passenger, this will be running, which will keep the aircraft electrically energized. You have got plenty of electric lights, and also give us air conditioning. At the moment, X has been switched off. We seeing in our TCAS, an aeroplane is coming, and it's about where are we? It's about 10 miles ahead of us. It's coming toward us, and it's going to cross over the aircraft. I can see it outside. It is coming and it's going to pass overhead by 1,000 feet. And if I look at it, it looks like an Airbus. Yeah, it is an Airbus A330 Qataria, and it is written Qataria. Now we're back to our explanation of the cockpit display. We were an air conditioning panel page, and it's written on the corner. It's called conditioning, and it is on the right showing temperature. And this is showing different zone of the aircraft and what temperature they are at, and what are the position of the temperature selectors. This gives an idea to the pilot of what the temperature in the cabin doing, and what is the automation doing to keep the temperature. And if the pilot want to change the temperature, you could come here. If you could just put your camera up on the overhead panel. These are the 2 which control the temperature in the cockpit. These plus some other panel on the cabin will make the integrated control over the temperatures. Okay, coming back here, we're going to see a door page. This door page is showing the cabin of the aircraft. At the moment here, we are on the cruise, and it shows the door are closed, which means they are green here, and it shows slides, mean that although the slide and the door for evacuation, it is arm and is there. Also shows the oxygen, the pilot oxygen. We have pilot oxygen and passenger oxygen. This shows pilot oxygen 1586, and that's usually we have 1800 maximum, but this is a usual indication at this thing, and it is plenty of oxygen. If we have a depressurization flight, if happen, that oxygen will be sufficient quite a lot. And in the bottom, it shows again vertical indication of the cabin. The cabin is neither climbing or descending. So this is a door page. Coming back to the next one, wheel page. Of course, this wheel page at the moment is not a requirement page, but it will show you that these are the main wheel pages showing its pressure and its temperatures of each tire. It's very important to see the pressure and temperature of tires, because if the pressure goes up or the temperature goes up, maybe the tire will explode. Generally, if you use too much braking, the heat generated into the temperature, it might cause the pressure to go up and it might cause explosion. So these are important indications on the wheel page to the pilot on the ground. At the moment, all the wheels are intact into the belly of the aircraft. Next page. flight control page shows all the surfaces at the moment, what they are doing, and all the different hydraulic supplying system to each surfaces here, and it shows you also the position of the surfaces and relative degrees to the aircraft. Next page, which is very important page, is the fuel. Fuel is a food for the aircraft. If you don't give food to the aircraft bite you back and drop down. So we want to make sure that all the time we have sufficient fuel. Now, this shows the distribution of the fuel over the wing of the aircraft and also the tail. There's another box here. So if you look at this represents the wing, left side wing. This represents the center position portion of the aircraft, which is in the cabin, but there is a tank on it underneath the cabin. And then this is the right wing. The left wing and right wing is also divided to inner and outers. So at the moment, if you can see, 11,700 on the inner, 2,800 on the outer, similar on the other side, and some fuel on the tail. The new design aircraft put fuel on the tail, especially the tail is filled, maximum is 4.8. And the cruise, it is usually filled up by the control of the fuel control computer, which will keep the center of the gravity of the aircraft to the optimum position. And that amount of fuel, although it's a little, it helps on the fuel economy aerodynamically. Coming back now, we've finished all that. There is one pages here, shows the circuit breaker page. Each aircraft, even your house, has got circuit breakers, and sometimes the circuit breakers either popped or have got something on it, and this shows it to us. And at the moment it says normal, so this means that there is no circuit breaker pop. There is another two switches here in the center here, and the status page. This page also is called the status. Okay, I have to hold it because it goes off. This status page is very important page for the pilot, mainly during abnormal operation and emergency, where it calculates a lot of things for the pilot. So it combines a lot of advisory information of what happens if the engine fail, or a flight control fail, or anything fails, any particular system failure on the aircraft, or any multiple system of failure on the aircraft. This pages is like a judging pages. It sums it up on a very nice way so that the pilot can look at it, and it's like an advisor page to the pilot. So a pilot comes and look at the advisor page, and that looking and reading the advisor page, it will give the pilot a good idea what is the status of the aircraft representing with relation to the failure or the emergency. And based on that pages, the pilot will make a decision now whether he can continue his flight all the way through, or continue his flight to the first en route destination, or make an emergency stop landing as soon as possible to the immediate available airport that it could take this aircraft. So it's a very important page. Now, this, all that which is hidden here now at the moment is not showing there, is called a flight engineer page on the past aircraft, and it's all been automated in here, and it comes when it is necessary. Now, we talked about the forward panel of the aircraft. Now, if you come to the pedestal also has got some instrumentation with some screen, which is, this screen is called FMC number 2, or FMGC number 2 and FMGC number 1. Flight Management Computer and Guidance. This is the heart of the guidance of the aircraft through the navigation system and the air. So this particular box, it is connected to the autopilot here. They are talking to each other. This box in the ground, the co-pilot mainly sits there for half an hour or 45 minutes during transit and feeds all the routes that it has been given to the aircraft for that particular day through the ATC and through the company. This routes is being then plugged into this and it is all filled in. Once the route is filled in, after the aircraft takes off, this aircraft information all linked to the center automation and the autopilot through this switch here and some of the switches here. Some of the switches here and this switch take care of connecting this, either this, the one to the right, which is number 2, or the one to the left, or number 1. So if we use autopilot 1, this will be the master controlling, talking to the autopilot. If we use number 2, then the autopilot 2 taking it from this. And we have some redundant system that we can either change both of them taking from 1 and 2 through this switching system here. But the important thing about this is all the route is on the computer now, and the computer is directing the autopilot of the aircraft to fly that particular route. And the aircraft just fly that particular route all the way up to the destination. So this particular explanation that I did is the particular explanation for the cruise. This is one mode of the operation of this aircraft. This aircraft also has got another mode of operation for landing. We can put the data for arrival, a particular approach that we want to do. Let's say that I am going to Bahrain, arrival, and I'm doing ILS. If you just put it here, you can see that now. So I show ILS here, and if I come and select here, ILS, it will show me ILS coming on this page. So from this, also I can select or my navigation instrument and radio setup for landing. So this not only navigate the aircraft on the air, it navigate the aircraft on the air to the top of the scene, to pick up the approach and all the way to landing. Okay, so that's enough about that. Now, the lower 2 instrumentation here are our communication setup. Very straightforward. We have got 2 communication VHF, 3 communication on VHF, 3 boxes. So we've got 3 setup of talking machines. We have got another 2 communication box HF. Plus we have got a lot of other redundancies that we can use. And this allows us to be able to listen to either channels. This is number 1. This is number 2. And on the top also we have another redundance panel of communication which has been put on the top. And this usually is being used by the pilot sitting at the back. Sometimes we have a checker sitting at the back and examining the pilot. So he wants to listen to all the channels, what's happening, all the communication. He uses this gadget on the top, and also he listens to the different headset which is behind the seat there. So this is enough about the center. If we come on the middle center of the thing is our throttle of each engine throttles, and this wheels shows the position of the tail of the aircraft in relations to the relative airflow, and this is all done automatically. The tail moves according to the speeds and the weight of the aircraft and temperature and all the bits and pieces. This part is the engine control of the aircraft. These are the master switches for the engine where we can put the engine on and off. This is the panel for the speed brake. We can use this to slow down the aircraft. It's called a speed brake. It's written on it. This particular lever here is called the flap lever. Flap lever is a lever which has got 4 positions, 1, 2, 3, 1, 2, 3, and full. And this, by selecting the flaps, as we're coming for approach to land, it will increases the area on the flow area of the wings. By this, it will enable the aircraft to fly a much slower speed on the air for landing. So the flap enable us to fly the aircraft at the slowest possible speed and still be flyable. And that's why we use this only for takeoff and landing. Now, if you look at the center panel here, again, we have another redundancy of this flight management computer, which could be a redundancy to this one. So if any one of them is failed, we can use this one. Now, on this one, there are a lot of other options that I didn't talk about. It will take really a couple of hours to talk about it. We can talk to the maintenance system. We can send telexes. We can receive telexes. We can receive weather from this. It's all now done automatically. You don't have to call the ATC and disturb the ATC. You can send the message to particular ATC, or you can send the message to your own center operation, and the operation will send you the weather. If you have anything en route problem that you want to divert, and you, of course, you are out of range with your main base, you send a message on a telex on this one, and the operations get set. Another thing on this one has got a maintenance. This has got a central maintenance computer. If any part of the aircraft fails all way or halfway or midway, or something gets hot and then cool, and some little things happen that doesn't come on front of the pilot, still the central maintenance computer will pick it up. It will send a signal to the main base. So probably main base knows today at this time that the oil of the aircraft has got little bit of debris on it, maybe ball bearing failure. It will not show, the engine will run normally, but the maintenance people know, say, we have little bit of chip detector detecting a debris on the oil. So this means that this aircraft, when it reaches Bahrain after 7 hours, they need to do a boroscoping of the engine, and maybe they need to change the engine after 3 days to reduce the maintenance cost. Because if this engine runs for 1 month, maybe it might cause a failure. So to prevent the failure, we will bring the maintenance program of the aircraft forward to save on the maintenance. Now we talked about the central, we talked about the front. Now we're going to talk about this eyebrow instrument. The glare shield is the instrumentation. Of course, they put it there because it should be on an easy access for both pilots. So if I look at there, I can reach almost all this instrumentation, and the pilot on the left-hand side also can reach all the instrumentation there. So this is flight control units. These are all the switches which through it we could feed a lot of information, either through to the autopilot or to the navigation tuning of the navigation instrument, or to changing the height of the aircraft, or changing the speed of the aircraft, of changing the mode display of the instrumentation. So this is becoming like a heart to all that. That's why it is there, and it is commonly used here. And the center part of it is the autopilot system with the flight director and the indication display on the top that has got a pilot usually don't have to touch it because it is usually controlled by the computer here. But if anything goes wrong, that the pilot wants to pick up anything, he can pick up, let's say, put his hand on this knob and turn the aircraft left or right of the airways. So you'll have direct control. So these are direct control access switches. This switch, I can change the speed of the aircraft. This switch, I can change the altitude of the aircraft. This switch, I can let the aircraft go up and down. These are the 4 modes that readily I need them available immediately. And plus the other switches can do a few other things. I think this is enough about that. And the indication here, it shows also part of the automation. It's called the EFIS, Electronic Flight Instrument System, where it will changes the displays here to the mode of the part of the approach that you're doing. If you're doing ILS approach, you can select ILS. If you're doing a VR approach, you can select VR, etc., etc. Similar sort of duplicate is there. So this is the glare shield eyebrow instrument. If we come on the top, all the way on the top, all the way back. These are the overhead panel of this A330 aircraft. It starts from some circuit breakers to the left and some circuit breakers to the right. These are the circuit breakers, and the term of this aircraft, we call them reset switches, where you can pull it on the cruise. It is allowed. Generally, any circuit breakers on the aircraft, you are not allowed to pull it on the cruise. But these are, because it is allowed to be pull it to reset the system, it is called circuit breakers and reset switches. So these are the main circuit breakers of the primary main instrumentation that you might need it. So it has been put there. This panel here are maintenance panel that mainly the engineer uses for checking system, loading things, checking the engine, etc., etc. So our pilotage things really start from this part. If we look at this side, we talked about this part, which is, we said this is a communication panel for the third pilot. This is communication panel for third pilot. Now, if we come down here, these are the three computers that controls the aircraft. This aircraft is controlled through computers. It's not a conventional aircraft where you can fly it by push rod and wire. This is called fly-by-wire. The fly-by-wire aircraft, and this aircraft, it flies through 5 computers. 3 of them has been latched in here. 2 of them has been put there on the captain side. But all the 5, they work together in harmony and control the aircraft through the flight control stick. We don't have a normal flight control, but we have here something called a joystick. If you can see it here, I'm going to put my hand here, joystick. This is joystick, and this sends signal to these computers and fly the aircraft. On the right, on the left-hand side, also there is same joystick, which captain can fly the aircraft. So if the captain is flying it, you see his hand is there. My hand is not on the control. If I'm flying it, I'm going to flying it through my right-hand side. And of course, there is a push button on each side that either one of us can disengage and control from each side. Okay. Now, we talked about this computer. This is called flight control computers. It's got a lot of mode, but it's enough to say that these are the main master switches which controls the computers to allow the aircraft and the pilot to fly the aircraft through the fly-by-wire, through the joysticks. I don't know why they call it joysticks, but this is what is the name of it, okay? Now, coming back down here, it is written cargo air conditioning. These are 2 switches which will allow the pilot to heat up or cool the cargo on the bottom of the aircraft. So he said to me, why you need temperature control on the cargo? In the air at high altitude, the temperature could be very cold and it could damage something, especially if you got vegetables or if you have live animal. So live animal need air conditionings and air and temperature control. So temperature control is done here. So these are part of the air conditioning and control for the cargos. Coming lower this part, we have a cargo smoke. This part controls the cargo protection against if there is any smoke or any fire developed on the cargo. We get indication here and we can have a control over it, and we have extinguishers that we can switch it on and take care of the fire. And also then we have got indication here which will show if the smoke is gone off or on. So at the moment it is showing smoke because I put the test switch on. So if the smoke goes off, it will go blank, and then the pilot know that that smoke or fire which has developed, it has gone off. 2 systems we have which is controlling the 3 cargo compartments. The backside is common to controlling 2 and the forward controlling 1. So we have 3 cargo compartments controlled by 2 systems. This is a ventilation panel which control mainly ventilation of air through some air fans to ventilate the instrumentation of the cockpit and the cabin. And this particular 4 switches are also belong to the engine. It's called engine N1 and engine manual start. If we have problem with the engine, at the moment the engine is controlling itself on a full engine digital control mode, and it's called FADEC. FADEC is really controlling the engine on all the modes, so there is no pilot interference on it. Sometimes the FADEC could fail, and the FADEC fails and we want to control that engine partially, then we use some of these switches and we either control that particular engine through the N1 modes, and sometimes we control the engine startup through the switches. So we have direct access switches to control the startup on the ground through the switches, or control the mode of the aircraft through the switches on the air. Now, this is this panel. Now we're coming to the center panel, and then I go to the other panel. Now the center panel is a common panel again to both myself and my friend the captain. It is displaying all the system panel on the top, on the switch, displays the switches. It is important to have that panel, although the system is hidden as an indication, but the system has to be here as a switches, because in order the pilot to control over the systems, he need to have the access of the switches. So the switches are being distributed on different panel to give pilot access to control. So if we took from the top here, we have engine 1, fire, engine 2, fire. So if we have engine fire, we're gonna get this sort of thing. A red light comes on, and that will be indication with some sound to tell us that we have engine fire. At the moment, I'm just pressing these test switches. So pilot then can fiddle with these switches and fiddle with these 2 switches. By doing that, he will eliminate air and fuel to that engine, and he will activate the extinguishers until he put the fire out. We got 2 extinguishers per engine. So these are the engine. Coming back immediately lower, this page is 2 pages. The top page is the hydraulic page, which is controlling all the hydraulic pumps. Hydraulic pumps sends hydraulic liquids under pressure, which are the muscles which fly the controls. Next one is we have the fuel panel. Fuel panel, we saw the system there on the system display. These switches are controlling that system there. So if I put fuel panel there, the representing of all these boxes are representing of the switches. So all the switches here are representing on the system there. So whenever I want to switch any of the panel, first of all I will select that panel, and then I will follow through the procedure and either switch off or on. I don't do it in a random mode. I follow a particular checklist, and I unswitch one of the switches, and I'll see the result, and based on the checklist I will either do the particular action or make some decision. So these are the systems switches. So if we want to go to electric, which is this one, I have to put the electric switch on and the board on there, and then come on the top and say, okay, I'm on electric, and I have control over generators, control over the APU generators, control over the batteries, control over the commercial power supply, control of the essential system, and so on. So this panel representing to the panel there. If I come to the air system, I have 2 systems showing here. The air bleeds and the pressurization. These are all combined on this. I can fiddle with the switches according to checklist. Both I can look at it up what I'm doing here, and it will be reflected as an indication there. Now, these are the miscellaneous panel. This miscellaneous panel has got APU in the center, which is two switches where I can start the APU and control the APU. On the right hand side, there are some switches, lighting switches, compass lighting, the overhead cockpit lighting, some test switches, the seatbelt on sign lighting, no smoking sign that the pilot could put on during takeoff and landing. Coming back to the left side is the control of all the lights, landing gear lights, all the approach lights that the pilot put on for landing. The main landing gear light, the nose wheel Gandhi light, and also the nose wheel lights. So all the lights are here. So now we've covered this panel, and we covered the center panel, and now we're going to cover the left panel. Actually, the left panel is not duplicate of the right panel. It's got completely different system on it. So the left panel starts from the top here. It's called ADIRS, Air Data Inertial Reference System. So these are a duplicate system. The inertial system has got 3 gyroscopic, laser type gyroscopic, which feeds information to our flight system to show the aircraft and relative to the azimuth, whether it is climbing, descending, turning, tilting up, tilting down. So we have 3 systems on the inertial referencing, which are these one, and these are controlling our flight indication instrumentation PFD there, which gets signal from there, and this instrumentation, mainly the center one, this one takes from there. The lower switches is called air data. So we got inertials and air data. The air data is the data which is relative to the air. The air is what? Is airspeed. So we need airspeed, indication system here, airspeed to the pilot up and down is all controlled from that. Okay. Coming back to the next panel here, it is written at APU. Yes, you can see it. APU panel is the panel that shows the condition of the APU with regard to fire. The control of the APU was here, but if we get any problem with the APU in relation to fire, we're going to get this light coming on, and we deal with the APU and we shut it down and we look after it. So we can control the APU fire by sending extinguisher agents inside the APU and turning the APU fire down. This panel, small panel there, is called flight control panel, which is part also of this panel here. When I say that these are the flight control computer. 3 computers are here and 2 computers are there. These are the 5 computers which are controlling the aircraft and the flight-by-wire system with the joysticks. 1 computer is enough to fly the aircraft safely to the ground, and the aircraft has got 5. This other switch is here called a turbulence mode. If the aircraft goes in turbulent mode, maybe you can switch this on and off depending on the system to find a comfortable position. This panel here is called fuel. Although the fuel panel that I show you was here, the main fuel panel, there is an extension of it, a small extension of it has been put there. And the designer designed it this way because this panel we don't use it so often. It's an emergency panel. You don't want to mix it with a normal panel. So if you put this and this, you mix it up, maybe the pilot fiddle with it while he's dealing with a normal thing. So it's been put in a corner and you're only using it on emergency, and this panel is all covered. As well as there are some panels, switches are all covered, they are only used for emergency and when things are wrong, and the idea of covered is mean that I don't fiddle with it. If I want to fiddle with it or put it on and off, I must get a confirmation that I'm doing the right thing. Okay. The lower panel is called evacuation panel. If I have problem on the aircraft and something is wrong that I need to talk to the back cabin, give them direct order of emergency for evacuate. These are the switches that if I press it, it will just give command evacuate, evacuate. Now, and this will give beep signal at each door. The lower part here also is a part of electric. We have a normal panel here. The extension panel is only used on emergency. This is controls the electric emergency when we have got problem with the electric. Lower part here is called GPWS. If you could look at it there, ground proximity warning system. These are switches that controls the aircraft computer, which will enable the aircraft and inhibit the aircraft to fly into terrain. So if the aircraft is flying into terrain, these switches, when it is on, with their associated computer, gives enough display on display panel here and warning to the pilot to tell them that they are approaching a terrain area. If the pilot is still not recognizing that particular danger that they are approaching, then the system will give them a warning. If that warning is also ignored by the pilot, then the system goes into the emergency mode and it will send a command signal that says, oop, oop, pull up, pull up. Then it will give you direct command, which means that now you haven't done anything. Now I'm going to say to you, you must pull up, which means that keep the aircraft climbing, otherwise you're going to hit the mountain. So these are very important instrumentation and automation that has been fed and set on the aircraft. The self-discovery of this part of automation came into effect, I think, after 1970s. And then they started developing it into more advanced system and more advanced system. And at the moment we have, the Airbus has got the most up-to-date and advanced system that we have. Coming back down here, we have the recorder switches, the flight recorder switches, which is very straightforward, and oxygen switches. This is controlling the oxygen of the pilot oxygen, and also this one is controlling the cabin oxygen. So if anything goes wrong, that the cabin level of oxygen drops, let's say that there is a leak of the aircraft or sudden decompression, we can press that switches, and that switches immediately drop dropout unit, which gives you continuous oxygen for 15 to 22 minutes. The lower part panel here are all push buttons here, and also this is one is called emergency push button. These are push button like the push button bell that you got on your house. If you press them, you press the bell. Bell comes on, and your servant opened the door. Here we have got so many zones. So there are 1, 2, 3, 4, 8 zones, 8 switches. If I want to call somebody from aft cabin, I'm going to press that one. It will not disturb all the passenger. It will only disturb that particular zone. It will beep them, and the lady which is at the back end near the toilet picks up the phone, and I can talk to her. Said, lady at the back, who's at the back? Is the supervisor at the back, and so on. So I can inquire with her and so on. So these are our communication system. These two switches wiper called, very small, one here, one here. These are controlling the wiper on left side and wiper on right side. I think in this very short introduction, it was pleasure to talk about the aircraft system and how we get the indication and how we deal with emergency. Maybe I was talking too fast and maybe I missed anything. So now I'm going to ask our friend Captain Mohammed if you have anything to add. Captain Mohammed is the commander of the flight at the moment. He was listening to me very quietly and smiling at me. I don't know what he's going to say to us. I will leave the last thing to you to talk about if you want to talk.
You've covered everything on this aircraft. The glass cockpit. Maybe you forgot the analog panels down here.
Yeah, I didn't. Okay, maybe you could look at
Yes,
that.
so if we do lose all our panels and not much electrics around, we can fly on these analog panels. We have the old horizon indicators, DMEs, altitude, altimeter, and our speed indicator. Worst comes to worst, we still have our analog instruments to fly with. But other than that, everything was covered by Captain Mahmoud. Sorry. Thank you.
Okay, then thank you very much, Captain. It was a pleasure again to talk to you about this glass cockpit, and we hope that we get opportunity in future to talk a little bit more, maybe about procedures and lesson plans and what pilot go through at different phase of the flight and years and the flight simulators, where they do their training, how they get qualified. And this is a very interesting subject for people to know that the pilot really goes and there are very intensive training and qualification to get the license. And once he gets the license, it's not only that, he will have to get also certification of first class medical. And not only that, every 6 months, the pilot then will be examined again on all the knowledge of all the system that I described. He should know it inside out. He should be able to know inside out how to handle the emergency. He will be given emergency, but not on the aircraft, on that flight simulator, which will look exactly like the cockpit, but it is on the ground. It's about 4-hour session, and hopefully one day with my friend here is going to come and take photos and videos of what Gulf Air does on their flight simulator training. Thank you very much, and I'd like to thank my friend for flying with us on GF 154 flying to Bahrain. At the moment, we have another 5 hours to go to Bahrain, and we're showing that we will be landing at 5 minutes past 5. And this system here shows that there is 1,879 nautical mile still to go to reach Bahrain. So we have to just sit there patiently, fly the aircraft, talk to different ATC unit as we go on. And at the moment, I think the captain agreed that we are crossing into India, yeah? Maybe you can talk about a little bit about India and where we are at the moment. So maybe Mohammed, you can talk about where is our ATC and the situation of the aircraft on the air.
We've just entered the southern part of India, and where are our airports? That's Hyderabad and Nagpur down there. I'll show it to you on our beloved iPad. There you go. That's where we are, Victor Zulu. We just passed it. In relation to India, it's the southern part of India, Victor Zulu, and we'll be exiting India somewhere north of Bombay. Victor Alpha Bravo Bravo. That's where Bombay is. Route will be taking us across the Arabian Gulf, UAE, before we start our descent for Bahrain. As Captain Mahmoud said, we still have about 5 hours to go and about 1,900 nautical miles. We're about halfway through our flight. These airports we use for en route alternates in case anything does go wrong, or if we have a medical emergency or any kind of emergency. We have airports along the route which we can land at. Hyderabad being one of them. The next one will be Bombay. Weather has been checked for all these airports, and if required, they are available for our use. Other than that, we'll just sit here now for the next 5 hours till we get home.
But of course, we just sit here, we monitor the flight, we monitor the other aircraft talking to each other, we monitor the fuels, and we also keep in the flight log, which is being looked after through both pilots, and we just cross-check. This is a manual flight log that we have to check through all the flight plan, and we write down how the aircraft is performing and in reference to the automation. So if there is any gross error, this will pick it up, which will alert the pilot. The pilot will come to the automation, make some investigation, and then we'll find out whether he's going to be arriving with the right amount of fuel, or there is some problem, or there's some fuel logging. So at the moment, although we're sitting here drinking and maybe every now and then talking to each other, but we're keeping an eye on they call it the flight watch, monitoring the flight, keeping in touch with the ATC at all time, monitoring the flight for fuel position checks and the accuracy of the navigation checks, and also monitoring the flight warning computer for any warning which could come possibly to warn us of an indication. Hopefully this flight for another 5 hours is going to be eventless, and we will be flying to Bahrain hopefully on time and normally. Just now Captain Mohammed said to me, we're flying at 38,000. The computer saying to us, hey, it is good to go a little bit higher to fly at, and instead of being at 38,000, please go up 2,000 feet more up, which is called go up 40,000. So at the moment, my friend Mohammed, Captain Mohammed is talking to them, to Bombay control, to try to get us clearance in order to go up. Maybe if you could put this on, yeah? Not. Yeah. To not.
Nagpur.
Yeah,
Maybe
okay.
another 3-4 minutes.
Yeah.
We'll get them. We will ask for higher altitude.
So the plan for the next 10 minutes is talk to the next controller. Once we establish communication, we put our request, which is, please, we are requesting a climb from 38,000 feet to 40,000 feet. Now, why are we doing that? The aircraft at the moment, the computer of the aircraft is showing that for little bit much better economy, fuel economy, is better to go up 2,000 feet, which has been calculated both by the aircraft and it has been confirmed by the paper which is in my hand. Maybe by going up, I might become 5% fuel efficient for the entire list of the flight. So this means I'm going to save a couple hundred kilograms of the fuel by going up. Now our task is to go up not on our own. We have to make sure that the airspace is free of the aircraft.
Good afternoon, flight level 360.
Comes from the ATC control. ATC control will give us that particular clearance once he finds that his airspace is clear, and then we will climb the aircraft to that thing. So when it comes in, you will see few changes. You'll see the captain turning this knob, changing this to different setting, and then he pulls. Once he pulls that, you'll see thing changes here. Engine's gonna go more power, and here on the flight instrument, it will shows that the aircraft slowly gaining altitude. And this is all will come in few minutes from now. So you have to be just patient, wait until we get the clearance. We're gonna then execute our clearance, and all this thing will be recorded as a data.
Gulf Air 155 radar identified. Confirm flight level 380.
FM, we are level 380, request level 400.
Gulf Air 155 radar standby. Climb to flight level 400.
Okay.
Confirm flight level 400, Gulf Air 155.
Affirm.
Okay, I have control. Okay, now we're gonna climb. So I'm gonna dial this to 40,000, indicated there, and I'm gonna pull this, which is mean I'm giving command to the autopilot.
400.
Confirm you cleared this, we're climbing 3400 now.
Roger, climb to flight level 400.
Climb 400, Gulf Air 155.
Okay, now we started to climb 400. If you come here, 400 showing here as a target, and at the moment we're slowly climbing from 38,400, and now this instrumentation which was dead before, you see, Now it's working. It said you are climbing 1,000 feet every minute to get to the 40,000. This is this part here, center. Here, the cabin started climbing to a higher level to maintain our pressure differential on the aircraft. And the top, the engine instrumentation, the power, engine pressure ratio, and the TGT has gone a little bit higher because we have increased the power from cruise setting into the climb setting. Climb setting is about 15% to 20%, depends where you are, is higher than the cruise setting, depending on the weight. So at the moment, we got 1,000 to go, see? At the moment, we are a little bit higher power setting because we need that power to climb the aircraft at the same speed. Now, once we level off, the thing will go reverse. This comes down to 0, and the engine goes back, not to that previous setting. It will go to the previous setting, maybe just a little bit higher because you are at high altitude. Yeah. Okay, I can show the engine instrument here while it is. Yeah, okay, where are we? Okay, yeah. See, this is now, I'm transferring the engine instrument panel here so that you can see them together. I sort of pitched this and put a duplicate of it here. Now we're leveling off, look, this is coming down to 4,000. Things are changing here, altitude is changing. This is dropping slowly. As this is dropping, look, the power is coming back. The gauges are turning slowly toward anti-clockwise. And we're getting annunciated to say, hey, you are at the required throttle altitude, alt cruise with green. And the setup is gone back a little bit to much lower climb setting.
Level 400, Gulf Air 155. Roger. Good afternoon, level 400.
Qatari Gulf Air 155, your radar contact maintained level 400 to continue flight plan route.
Flight plan route 400, Gulf Air 155.
Arabia 374, descend level 250.
Descend 250, Arabia 374.
Arabia Gulf Air 155, 118925.
18925, Gulf Air 155. Gulf Air 155, good afternoon, level 400.
Gulf Air 155, good afternoon, roger.
UAE Python 74, level 340.
Python 74, roger. MS-803, UAE Center, identified off the Miata, Mike 318, climb flight level 240.
Miata, Mike 318, climb level 240, Emirates 803.
feet route. MDA 06. Engine start select. ESB. What will be your gate?
Got VS.
Okay. Check. FMA localizer. Localizer start. Gulf Air 155 established localizer 30 right.
2,500.
Gulf Air 155, thank you, clear for the approach, 9 miles from Taydon, Bahrain Tower 118 smooth 5 بالسلامة.
Gulf Air 155 11851. شكرا. Bahrain Tower Gulf Air 155 9 miles 30 right. Good afternoon.
Good afternoon, Gulf Air 155, continue approach 30 right.
Continue approach 30 right. Gulf Air 155.
Arabia 106, start the pushback, is
Light
approved to face east.
You know.
Approved, facing East Arabia 106.
Okay. Same thing. 116 not 150 knots.
Flaps full.
Flaps full. Speed check.
Land checks.
Okay. Cabin crew.
Advised.
Auto thrust.
Speed.
Auto brakes.
Low.
Okay, checks is complete. We clear to land. Wind is 15 knots.
Check. 3 miles.
Check 3 miles.
Bahrain ground 021.
F31, go to Khoi.
طال عمرك, runway taxi inspection is done and vacated at 54.
Islam.
500. Looks good.
400.
400.
Land green.
Land green.
100 above.
That above.
Check.
Minimum.
Autopilot.
Okay, minimum.
$100. 50,
She doesn't
40,
want to like this.
30, 20, retard, re 10.
Okay. Spoilers, reversers. $70 knots.
Check. Manual braking.
Okay.
Gulf Air 155, vacate Delta Alpha Cubic, stand 13,
Give way to the Arabi will taxi shortly, then continue to the stand.
Tower, assalamu alaikum, مساء الخير. تم final 30 right.
Noor Saudi 520,
Okay.
continue approach 30 right.
Okay, after landing reads flaps.
Qatari 1110, wind is showing 3.
Okay, he's moving now, so we can continue, yeah? Spoilers.
Hi, welcome to Bahrain. Another successful mission. One thing which is proven from this flight and other flights is that good teamwork, good preparation makes life easier for everyone. So welcome to Bahrain. Thank you for flying with Gulf Air.